According to a recent article, 32% of drivers had driven drowsy in the past month. Law enforcement officials are planning a survey of 1,000 drivers to determine what proportion are driving drowsy. Describe the sampling distribution of p-hat, the sample proportion of drivers who had driven drowsy. So, couple of conditions that we need to check for here is we want to check that the sample size is less than or equal to 5% of the population size, and n times p times 1 minus p is greater than or equal to 10. If those conditions are true, then we can say that our sampling distribution is approximately normal. So we're looking at a survey of 1,000 drivers. So we just kind of plug that in here. And if we substitute that in, look at this here, looking at 2,000. And we don't really know our population here, but we can kind of totally think about it. That's probably, we're looking at like the U.S. or something of that nature, since we're talking about the nation's health here. That's probably smaller than 5% of the population, so we're good to go here. So then we're going to check our other condition. So our other condition here is that n times p times 1 minus p is less than or equal to 10. So n is 1,000 and p is 0.32. So we calculate this out. So 1,000 times 0.32 times 1 minus 0.32. We get 217.6, which is greater than or equal to 10. So we know that it's normal. So now let's calculate our mean and standard deviation. So our mean of the sampling distribution of the same proportion is equal to p, so that is 0.32, and sigma, so p hat, is the square root of p times 1 minus p over n. So that's going to be 0.32, 1 minus 0.32 over 1,000, and then take the square root of all that. So I actually like to kind of break this down into steps, so let's do that. And then it makes it a little bit easier to type in the calculator. So 1 minus 0.32 is 0.68 times 0.32 is 0.2176 over 1,000. Divide that by 1,000. Don't really get a nice number there, so I'm just going to leave that in this form. They usually like to approximate this to 6 decimal places, so let's go ahead and take the square root of that. So square root of that, so 0.014751. So we're going to say here that the sampling distribution of p hat is approximately normal with mean 0.32 and standard deviation 0.014751. So next question we want to know, in the random sample of 1,000 drivers, what's the probability that more than 30% of the drivers will have driven drowsy? So we want to know, what's the probability that P hat is greater than 30? So again, normal CDF. And lower bound, upper bound, and then our mean, which was 0.32, and then our standard deviation, which was the square root of 0.2176 divided by 1,000. So use that whole thing there, or at least 6 decimal places will keep you from getting a rounding problem there. So I'm going to type that in and see what we get. So we're going to do second vars 2, 0.3, comma, 1 second, comma, E99, comma, 0.32, comma, second squared, which will give us the square root, 0.2176 divided by 1,000. Close my parenthesis, close it again, enter. So this is 0.9124. So that is actually quite a high percentage. So moving on to the next part. So we want to know, would it be unusual if in a random sample of 1,000 drivers, 35% or more were driving drowsy in the last month? So we were looking at probability that P hat is greater than or equal to 0.35. So again, normal CDF, 0.35, 1 E99, our mean of 32%, and then our standard deviation there of 0.2176 divided by 1,000, and then take the square root of all that. So let's see what we get here. So second vars 2, 0.35, comma, 1 E99, comma, 0.32, comma, second x squared will give us a square root, 0.2176 divided by 1,000. Close our parenthesis to end the square root, close it again to end normal CDF, and we get 0.02 and 0.9, but then there's 8, so 1, 0. And that would not be unusual since our probability there is less than 5%. The last part here, we know what's the minimum number of drivers that must be sampled to be sure that P hat is approximately normal. So our main condition here is N times P times 1 minus P needs to be greater than or equal to 10. So going for what is N, so that this condition is equal to 10. And usually we round up, and that way we ensure that it in fact does equal 10, because if we round down, we're not sure, then that will equal 10, and then our condition is not satisfied. We just use equal to, so it's easier to solve. So P is 0.32. So we're going to plug that in and solve for N. Remember before, P times 1 minus P was 0.2176. So N is multiplied by that value, so when it's multiplied, we can divide. And that'll get N by itself. So we get N is approximately equal to, okay, so 10 divided by 0.2176. This is 45.96. And we always round up. So in this case, we would round up naturally. But if it were 45.0001, we would still round up to 46. So we need to sample 46 drivers there. Oops.